please. Hope you are all fine. And today we shall have a chemistry lesson. And this is week 3. And this is our first lesson together. And I hope we shall have a good one if we cooperate. All that we need is to make sure that whatever is near you that is likely to distract you, you better put it far from you. And we go on smoothly. So I'm going to request one of you to give us an opening prayer so that we can start our lesson when God is amidst us. And maybe before the prayer, I also request that those who are not having their names, instead you're having the name of the device you're using, can be a phone or a computer, please, you name yourself. I am saying Infinite Hot 10 and others, please make sure you put your name so that you can easily identify you. If you don't do that, in case if there is any question, you will not be picked. So let me request, I'm going to request Jonathan. Jonathan can give us a short prayer. Jonathan, please unmute and give us a short prayer. Okay.
Hello.
Yes, hello.
I'll pray. Our Father in heaven, I thank you for the gift of the day you have given to us, Father. As we are going into the lesson, Father, may you please help the teacher who is going to teach us, pass to us the knowledge we have to get properly, Father. We pray that everything we study remains in our head and be of benefit to us. Amen.
Amen. Thank you, Jonathan.
Okay.
So my name is Teacher MUGUMYA OSWARD. I'm a chemistry teacher.
Okay.
And from now, we shall be going through chemistry together. And I hope we shall all enjoy. So we are going to look at a new topic to some of us. You might find that some of us have already looked at it, others we haven't. But as long as we are all here, we are one family. So whether you have looked at it or not, let's cooperate and we don't distract others. And question that if you misuse the chat, then the rights will be taken away. So if you over chat, then your rights will be taken away. All right. So we are going to look at a new topic to some of us, and that is chlorine. That is chlorine and its compounds. Let me share the screen. Okay. So we are going to look at that topic, chlorine and its compounds. So this is an element that most of us have always heard of from senior 1. We have always heard of chlorine. So today we are going to look at chlorine in detail. We are going to look at chlorine alone, and later after we look at its compounds. So we need to first identify where do we find chlorine. Chlorine is in group 7 in the periodic table, meaning that if you remember very well how we determine the group of a given element, we look at the number of electrons in the outermost shell, or what we can call energy level. So in other words, chlorine has 7 electrons. It also has an atomic number of 17. If you are to write its electronic configuration, it would be, if it has atomic number of 17, then it means that the configuration would be 2, then to 8, then to 7. That would be its electronic configuration. And like I said, it is in group 7 because it has 7 electrons in the energy. So we can say that in group 7, we have the other elements. We have the other elements and they are non-metals. So group 7 has only non-metals, and we can say that there are these group 7 elements that are the most reactive non-metals. And in that group, we have fluorine as the first one, then followed by chlorine, bromine, and iodine. So that's the order. We start with fluorine, chlorine, bromine, and iodine. And again, they make up a family of related elements, and they have their general name. So group 7 elements, they have their general name. At times we call it collective name. So we call them halogens. Just like some of you who have family names, you find that whoever is born in that family has got a common name. So also the group 7 elements, that family or that group, we call them halogens. So in case if they asked you, let's say in paper 1, they're asking which of the following elements is a halogen. So you have to pick, you have to look at the answers and see any element which belongs to group 7. It can be either fluorine, chlorine, bromine, or iodine. I hope that one is clear. So when we continue, the meaning of the word halogens, it means that these are salt producers. These are salt producers. I have a feeling that most of us have covered salt, either in senior 2 or senior 3 first term. So before we proceed, can we have someone to remind us what a salt is? Anybody can remind us, who can define for us a salt? Very fast, raise up your hand. A salt, what is a salt? If you know that you still remember the definition of a salt, you can remind us and we continue. A salt, what is a salt? Who can define for us a salt, please? Okay. Can remind us, Charlotte. I hope that's the right pronunciation. You can unmute.
Okay. So are you hearing me?
Clearly.
A salt is a compound consisting of positive metallic or ammonium ions and negative ions which are derived from an acid.
Okay.
Yes.
I hope everyone has had the definition. Thank you so much. So for the interest of time, we can continue since we have been reminded about what a salt is. So we are saying that these halogens are salt producers since they react with most metals, to form electrovalent salts, like compounds. Electrovalent salts, just like how we have acids. Acids react with metals to form a salt, electrovalent salt. If you don't want to use the word electrovalent, you can use the word ionic. Remember, also in senior 2, we say that we can form an electrovalent salt or an ionic salt when we have a metal and a non-metal. So here we are saying that whenever halogen reacts with chlorine, or whenever halogen reacts with a metal, we form an electrovalent salt. Someone is asking if we can repeat the definition of a salt. Okay, we shall request Charlotte when we go back to define for us, to hear what she said. Yes. Your hand is up. Sorry about that, had gone off. Maybe before we go back to the sharing, Charlotte, the person who defined for us a salt, you can define it. Raise up your hand. Yes. Charlotte, define for us the salt the way you did it so that someone can hear.
Okay. A salt is a compound consisting of positive metallic or ammonium ions and negative ions which are derived from an acid.
All right. So I have a feeling that someone was asking. You now got it. Robinson, if you have not heard, you can raise up your hand. Okay, I hope he has heard. Yes, Blessing. Blessing.
Yes, please.
I see your hand up.
I was asking her to repeat for us the definition.
Okay, for the last time, Charlotte?
Yes.
A salt is a compound consisting of positive metallic or ammonium ions and negative ions which are derived from an acid.
Okay, thank you.
Welcome.
So that was the last time. Since we are recording, we shall go back and we have to remind ourselves. So someone is asking whether chlorine is a free element. Yeah, don't worry, we are going there. That's where we are heading to. We are heading that part. We are going to look at it and see if it is a free element. So we continue. We look at the preparation. Maybe to answer the other question, yeah, we can mostly find chlorine in other compounds. We find chlorine in other compounds. In other words, it is not a free element. Normally, we find it in other compounds. Okay. So as we continue, we want to look at the preparation of chlorine. So here I want us all to pay attention and we look at this preparation step by step. So we are starting with what we call a laboratory preparation. What we are going to look at is a laboratory preparation. So we say that chlorine can be generally prepared by removal of hydrogen from hydrochloric acid. General, meaning this is the general method, or we can say this is the common method, prepared by the removal of hydrogen from hydrochloric acid. And before we proceed, how can we term the removal of hydrogen from a substance or from a compound? And in this case, we are having the removal of hydrogen from hydrochloric acid. What term can we use? What do we mean there? Who can tell us? Removal of hydrogen from a compound. Removal of hydrogen from a compound. How can we term it? Can I assume that these hands are going to give me the answer, or they were up already? Yes, Emmanuel? Emmanuel, you can unmute. Emmanuel, unmute and give us the answer. Emmanuel, I'm not hearing you. I don't know whether it is my network or yours. We are unable to.
Teacher.
Yes, please. Let's get another one. We can have Trevor. How can we term the removal of hydrogen from a compound?
Oxidation.
Oxidation. Thank you so much. So we can term the removal of hydrogen from a compound, and in this case we are having hydrochloric acid as oxidation. I remember that we define oxidation in three ways. We can define it as addition of oxygen to a substance, that is the common one, or we can define it as the removal of hydrogen from a compound, or we can define it as the loss of electrons. So those are three ways of how we can define So this can be done by an oxidizing agent, and that will combine with hydrogen to form water. Then the oxygen for the oxidation of hydrochloric acid is provided by any of the following. So we want to look at the different oxidizing agents that we use under the preparation of chlorine gas. So we have different oxidizing agents. We have the common ones, and we have also those ones which are not common. So at this time, we are going to request those who have maybe looked at chlorine and its compounds to help us give us any of the oxidizing agents using the preparation of a, you can help. Yes, Hakim. Hakim, do you have the answer? Hakim?
I'm sorry, I just forgot to lower my hand.
All right. Anybody who could be knowing? Yes, Robina. Robina, you can unmute.
Potassium
I beg your pardon.
permanganate.
So we have potassium permanganate. Robina has said that we have potassium permanganate. Thank you. Another person, seeing JB. JB, unmute.
Yeah, it's lead. There is lead dioxide.
Sorry?
Lead dioxide.
Lead dioxide. JB
Yeah.
is saying that we have lead dioxide. That is the same as saying a lead for oxide. And again, for potassium permanganate, that is the same as potassium manganate 7. Okay, then Trevor, once again, hope this time you won't disappear. Trevor?
Manganese oxide.
We have manganese oxide, thank you. And now we can have Lona. There was someone, the hand was up after choosing her, she disappeared. Anybody else apart from JB? JB has already given us an answer. How about others? Who can try? Who can try? Trevor. Trevor, it seems you want to give us the answer. Lona is back. Yes, Lona. Seems Lona, you're playing games.
Sodium carbonate.
Sodium
Carbonate.
Sodium carbonate. Thank you for trying. We are remaining with only one. We are remaining with only one. We can have, I think that's Trevor. Trevor.
Trilate tetraoxide.
Trilate tetraoxide. So thank you. So we are having the first one. We are having potassium permanganate. Potassium permanganate, or what we can call potassium manganate 7. So you can see we have two names. So you can choose to either call it potassium manganate 7, or you can choose to call it potassium permanganate. And what we have in the bracket, this is the chemical formula. Then we also have manganese oxide, which is also having a chemical formula of this. Someone is saying that I'm breaking. At times I would break because of network, but as long as I remain online, then the network will be okay. Then we also have lead oxide. Lead oxide, or what someone called lead dioxide. So you can either call it lead oxide, or you can call it lead dioxide. Why do we call it di? It is because of having these two. So the word di means two, dioxide. So we have two oxides there. And in this case, lead is using a valency of 4. That's why we are putting the 4 in the bracket. And then finally, we have trilead tetraoxide. So these are the ones we normally use. These are the oxidizing agents we normally use in the preparation of chlorine gas. Okay, so amongst the four oxidizing agents, we have some which are common, which are very common. Amongst the four, we have those ones which some of you are very common in school. why you find that everyone almost knows you. Even those who have not yet joined, they know that you're there. Robinson, you're asking whether you're supposed to get notes. Yes, you'll get notes, but that will be after the lesson. I am going to post the notes, but that doesn't mean that you go away. You stay and you hear what I have to say. Some things are not in the notes. Some things I just say them out during the lesson. And that is why all of you are supposed to be having at least a book whereby you can just write down short notes according to what you understood. Okay, Robinson, you're welcome. So as I said that amongst the four, we have those ones which are very common. And those are, we have potassium permanganate, or what we call potassium manganate 7. And we also have manganese 4 oxide. So members, we have 2 common oxidizing agents. And these ones are picked from the 4 that we have. And that is potassium permanganate and manganese 4 oxide. So when we continue, now we want to look at how can we prepare chlorine from hydrochloric acid by oxidation with manganese 4 oxide. So we want to look at how we can prepare chlorine gas using an oxidizing agent of manganese 4 oxide. And remember, the hydrochloric acid is supposed to be concentrated. For the oxidation to take place, the hydrochloric acid must be concentrated. So that is why I was saying that some things are said during the lesson and are not in our notes. So here you're supposed to put there concentrated, the word concentrated, to make it concentrated hydrochloric acid. So procedure, what are those steps that we can follow to prepare chlorine in the lab? Someone is saying that I hadn't finished the previous page. Please replay it. This is, let me first get the name. Yeah, you're not supposed to copy what is on the screen, given that we shall get the notes. But my point was, in case you just try to summarize maybe what I'm talking. If I say out a point and maybe you think it is good to be written down, you can do that. But the notes will come. The notes will come, which are detailed. This is just a presentation. We are not giving you everything. Some things will be found in the notes. Then Robinson is asking, why not dilute? I mean, he means, why don't we use hydrochloric acid when it's dilute? It is because when it's dilute, it is going to act as an acid. It is going to act as a normal acid. So it won't allow to be oxidized. So make it concentrated so that it can be oxidized. I think that is right. Okay, you are welcome. So step one. Yes, Harriet. Harriet, your hand is up. Harriet, you unmute if you have any question.
Teacher,
Yes,
I've not
please.
understood the common oxides agents used in the preparation of chlorine.
Okay. So if we are to go back, someone is saying that she has not understood the common oxidizing agents. So like I said, that amongst the 4, the way we have them here, that is from Roman 1 to Roman 4, all these are oxidizing agents. But amongst the 4, we have those ones which are commonly used. which are commonly used, and that is potassium permanganate and manganese 4 oxide. I'm not saying that the rest are not used, they are also used, but we normally use potassium permanganate and manganese 4 oxide. And by the way, even after here we shall have to pick the best between potassium permanganate and manganese 4 oxide. So also between these two, we have the favorite, and we shall give the reasons. We shall have to support our answer for that. Okay, I hope Harriet have answered your question. Someone is asking whether the acid should be hot or cold. Normally concentrated acids are hot. Normally they are hot. But as long as the acid is concentrated, then to do the job. So we go back. So we're here that place the first procedure or the first step, place some manganese oxide into a flask. Lamps are preferably used as the powder is very reactive. So what do we mean here? Here we shall get manganese oxide and we put it in a flask. Manganese oxide is it is a black powder. It is a black powder. I don't know whether you carried out the preparation of oxygen using manganese oxide as a catalyst. If you happen to do that experiment, or if your teacher demonstrated it, then he or she should have shown you the color of manganese oxide. It is a black powder. It is a black powder. It is always in powder form. But again, we are saying lamp powder is very reactive. When we talk of lamps, in this case, we mean that these are big particles. These are big particles. So we prefer to use them because for them, the reaction will be very slow compared to when we have a powder. This one comes, we shall have the details when we go to rates of reaction, factors that affect the rates of reaction. And one of them is the size of the reacting particles. So in this case, we are having lamps. It's like when you have, you can use an example, when you have salt. There is this salt. Before that, we see what? Yes, Hakim.
Excuse me, teacher.
Yes, please.
Pardon about the procedure.
The procedure, we are still on number 1.
Yes.
Procedure number 1. Okay, I'm going to repeat for you.
Yeah.
Thank you. So once again, we are saying that place some manganese oxide into the flask. And we are trying to explain why do we use the lamps instead of the powder. Why do we prefer to use the lamps to powder? And I said lamps, these are big particles. We can call them big particles. And I was going to ask, if you had this rock salt, I hope everyone knows rock salt, the Baganda call it echisula, then the Banyankole call it echonde, other languages I don't know. So you find that the rock salt or echisula is big. It is always in big particles. And if you also have the table salt, this salt that we put in food, the white salt, which one do you think is going to dissolve faster? Which one do you think is going to dissolve faster? Once again, I said that if you don't have the name on your device, I will not allow you to talk, to ask a question. For example, this person who is taking F1. So I'm going to lower your hand. Yes, Musician.
The white salt will dissolve faster.
The white salt will dissolve faster. Okay, that is her opinion. Anybody else who has a different opinion? If you have a different opinion, please, you can raise up your hand. If you have a different opinion, you can raise up your hand. Michelle, should I say that you've changed your mind? I see your hand up. And please, after giving us the answer, it's always better if you lower your hand so that we don't get confused. Yes, Patience.
The rock salt dissolves faster.
The rock salt will dissolve faster. So Patience is saying that the rock salt will dissolve faster. And lastly, Marvin, what do you think?
Salt will dissolve faster.
He's saying the rock salt or the table salt?
The table salt.
Okay, thank you. So we are saying that the table salt will dissolve faster compared to the rock salt. So the same thing can be applied here. Whenever we have small particles, like those particles of a powder, and the reaction is taking place, each single particle, each small particle, each tiny particle contributes to the rate of reaction. So just imagine a number of particles in a powder. There are very many, and each one of them is contributing to the rate of reaction. When I talk of the rate of reaction, I mean the speed at which the reaction is taking place. Unlike if I have big particles, if they are big, it means that they will be few in number. They'll be few in number. If I have, for example, a kg of, if I have a kg of rock salt and a kg of table salt, you find that the rock salt has few particles and the other one has many particles.
Yes. Marvin? Marvin? Yes, Marvin. Sorry, the teacher went off. Marvin, what are you saying?
I wanted to ask what's going on.
I think the teacher went off and also my network jammed a bit. Let me communicate with him and he connects back. Okay?
Okay, thank you.
Mm.
Yeah.
So sorry about that. The teacher has connected back. Let's see, continue from where we had stopped.
Okay, thank you, Akuru. So we just need to continue from where we had stopped. And you can see just a few minutes when I was away, the chat is already full. So you can really see that you don't deserve the rights of discussing about the thing that we just shared. So we're here. On procedure one, and we're explaining that. So let's go to procedure 2. Procedure 2. We shall fit the apparatus as shown below. So we shall look at the apparatus. That's the diagram. And then after arranging your apparatus, as we shall see, then you add the concentrated hydrochloric acid down the funnel. So you can choose to use a test funnel.
Yes, sorry, the teacher is breaking and finally he has gone off completely. Sorry about that.
And that is our diagram. That is our diagram. And let's talk about this diagram. So you can see that this is the system we're talking about. And then we are adding, we have also manganese oxide in the flask, and you can see these are big particles. These are big particles, like we said, these are lumps. And then from there, after producing our chlorine from this flask, this round bottomed flask, and we apply heat, then we shall produce chlorine gas. We shall produce chlorine, then to pass through the delivery tube, like you can see. Then from there we pass the chlorine through water. We pass the chlorine through through water. So whenever we are using concentrated sulfuric acid with concentrated.
I think, colleagues, we should end this class. You can speak your views. Avan, you can unmute and speak. Yes. Can we end it?
Yes,
I
teacher.
think we
Because
can. Yeah.
Yeah, I think let's end it and then
Yes,
Thank
teacher.
you. Thank you.
Asano.
Guys, bye.
Bye, teacher.
because even it's
Okay,
already
never mind.
time.
Let's just go.
It's already time.
You guys log out.
Whatever.
So,
Bye,
Guys,
teacher.
next time,
Teacher.
coming back.
Goodbye. Next
Where can
time.
we get the notes if we
Well,
need
guys,
them?
don't forget.
the notes are in the Google
Forget.
Classroom. The notes are going to be put in the Google Classroom.
Okay,
Guys, don't
teacher.
forget
Thank you,
to
teacher.
go
So,
there.
let's
You're
go.
making noise. I'm writing nice sneakers.
Let's go in the
You
Google Classroom.
right.
Forgive us.
Type and go to Google Classroom. Okay. So you go to Google Classroom, and then when you reach there, so in Google Classroom, you go and find your class. So in Google Classroom, find for S3. So in that class of S3, you locate your work under classwork. So you can find the work in that drive for all
See
the
you
subjects.
tomorrow in math.
Okay,
at
so no
11.
assignment.
See you tomorrow. So assignments are there. You see, you go and attend to them. They are here. You see, the assignments are there. So attend to them and
Okay,
submit.
teacher.
Okay, bye.
Bye.
Teacher, you're going to put the
Guys,
notes for
bye.
chemistry.
Guys,
Yes, the teacher of chemistry is going to put them today.
Okay, thank you, teacher.
Okay,
So
bye.
what about the timetable?
Bye.
We don't have the timetable.
Yes.
Yes, tomorrow we have math at 11.
You can briefly look at the subjects you have. Tomorrow,
you guys,
Wednesday,
tomorrow,
tomorrow
math. Wow.
Thursday, you have math and geography. Okay?
Math at 11 geography.
11 geography at 2. Then on Friday, you have physics and English.
Teacher.
Okay, so we
Yes?
have seen.
Okay.
Thank you, sir.
Those who need the WhatsApp
Teacher,
group,
wait a bit. Teacher, wait a bit. Don't remove the timetable.
it's fine. It is still there.
Well, screenshot the timetable.
Sir,
Yes?
the WhatsApp group people are leaving because they are not chatting.
Yes, that chat is limited. We don't want too much nonsense there. Because once it is open, you are going to do a lot there.
But now those who
So
have
is there a
questions like
WhatsApp group? So is there a WhatsApp group?
I've sent
No,
the link in the
if
chat
we
for
have
those who want to
inquiries.
join the WhatsApp group. I've sent the link in the chat. Get it? It is the one you can use to join WhatsApp group and to join the Google Classroom.
Thank you, teacher.
Have
Okay,
you seen
thank
the
you,
link?
Mr. Bernard.
Welcome. Have a great day.
Bye.
Teacher, how do you join the WhatsApp?
I've said I've sent the
Send
link
the
in the
link.
chat. Look in the chat, the link is there.
Okay.
Bye.
Thank you, sir.
Welcome.
Tuanji Abi.